Okay, so we have here the method or the procedures in designing attention members. Okay, so una, we have to calculate the minimum gross area in yielding. So remember, we have two limit states when we're talking about tension members. The gross section yielding and the net section fracture. Okay, so dito, we have to calculate the minimum gross area in yielding. Okay, so equations are derived from the tension general code provision. So the given equation here for the LRFD and ASD is actually derived from the tension general code provision. If you still remember yung code provision natin for the tension member, the design tensile strength should be greater than or equal to the ultimate load. This is for the LRFD, and the allowable tensile strength should be greater or equal to the service loads. This is for the ASD. Okay? I hope you still remember these code provisions. Okay? So yung Rn natin, if we are talking of yielding, Rn is equal to FYAG. Tama? Okay? And phi, okay, given yan. Ano yung phi natin? Pagka LRFD, pinag-uusapan natin. This is 0 based on yielding. This is 0.9. And yung omega natin is 1.67. This is based on yielding. Okay? So rearranging, substituting this value or equation of Rn here, then rearranging our equation, makukuha natin that our minimum AG is equal to PU over phi times Fy, that is for the LRFD, and yung ASD, that is the PA times the omega over Fy. Okay? We have to calculate the minimum gross area and in yielding. Okay? So pagka na-calculate na natin yung minimum gross area, pwede na tayong mag-select ng ating steel section based on yielding. Okay? So that yung assumption natin, magkaka-idea na tayo sa estimated hole areas ng rupture. Diba? Kasi pagka nag-select tayo ng section, syempre kasali yan yung mga properties niya. Okay? So yun yung unang assumption natin for us to have an assumption doon sa ating estimated hole areas pagka kinonsider natin na ngayon yung effective area in rupture. Okay? So pagka meron na tayong steel section, meron na tayong properties, we have now to calculate the minimum effective area in rupture. Okay? So these equations given here are also derived from the tension general code provision. Okay? So from the general code provision, the same, that our design tensile strength should be greater or equal to PU, and our allowable tensile strength should be greater or equal to our service load, PA. Okay? However, yung Rn na natin ngayon, yung nominal strength na natin, if we are considering rupture, Rn is equal to Fu AE, right? Fu is given, that is the ultimate strength, and yung AE, this is given by the capital U times AN, yung shear log factor times AN. Okay? So, substituting these equations dito, makukuha na natin na ang minimum AG natin is equal to PU over phi times FU times U. This is for the LRFD plus estimated hole area. Plus estimated hole area. Okay? And then for the ASD, PA times the omega over phi omega alisin yung fee, wala yung fee. Kindly correct this, wala yung fee natin. Yan. Wala yung fee natin. Kindly correct this. That is over FU times U plus the estimated whole area. Okay? So this given equation are derived from tension code provision. So pagka alam nyo yung code provision, kahit hindi nyo niya i-memorize ito. Okay? As long as you know how to manipulate your given equation. Diba? AG ang kinukuha kasi natin. Remember, AG, gross area yan. Ang given sa nominal strength, pagka-rupture ang pinag-uusapan natin, AN. Okay? So the gross area is actually the net area plus the estimated whole area. Kasi pagka kinukuha natin yung net area, di ba? Mina-minus natin yung estimated whole area doon sa gross area. Okay? So if you know the code provisions and you know how to manipulate your equation, kahit hindi nyo na-memorize actually itong equations dito, kayang-kaya nyo nang isolve yung minimum AG. Okay? So we have now the minimum gross area based on the yielding and based on the rupture. Okay? So you have now to select your trial section based on the areas that are computed based from yielding and based from the rupture. Okay, so if you have now the trial section, the properties are known. Okay, so meron na kayong properties. So next is you have to check your trial section if it satisfies yung design strength natin, pagka LRFD yung method na ginamit, or yung allowable tensile design pagka ASD yung ginamit. Okay? That should be greater than the actual force load and service load. Okay? So yung makukuha dapat natin na design tensile strength or the allowable tensile strength should be greater than the actual factored load or service loads pagka allowable. Pagka okay siya, yung trial section ninyo is safe. So pwedeng gamitin yung trial section ninyo. Okay? But you also has to consider pagka sinabi sa problem that you are going to select the lightest or select the most economical. Diba? Pagka mas may mababa pa na, for example, ang trial section ninyo, W12 by 30. Okay? Safe siya. Okay? You still need to check if yung susunod na mas maliit dito, say W12 by 20 or 25, yung malapit sa 30. You have to check this. Yung section na W12 by, say, 25, yung mas malapit sa 30, yung mas mababa. Okay? If it satisfies your design tensile strength or your allowable tensile strength. Pagka nag-okay yan, ito yung pipiliin nyo. Mas economical siya since it is lighter. Okay? Kung ano yung mas lighter na section, yun yung mas economical since yung pagpili ng steel section is per kilo, yung weight niya. So if you notice sa AISC manual, meron tayong naka-indicate na weight ng standard section. Okay? So magbe-base din kayo sa weight. Okay? Pagka hindi naman na-satisfy, pagka hindi na-satisfy, pagka yung factored load niyo or yung service load niyo is mas malaki kaysa doon sa design tensile or the allowable, you have to select another trial section. Pagka hindi siya safe, mag-select kayo ulit ng trial section, yung mas mataas. Okay? Until masatisfy ninyo that your design tensile strength or your allowable tensile strength is greater than your actual factored load or service loads. Okay? So, paano nyo ito i-check? Paano nyo iti-check? O, gamitin nyo yung discussion natin last week, yung analysis of tension. Okay? So, pagka may trial section na kayo, you have to use the analysis of tension members. Yun na, para ma-check nyo if your design or allowable is greater than your factored. Okay? So, pagka meron na kayo dito, na-check nyo na, safe siya, okay na yung trial section ninyo, yun na yung trial section. However, you also have to consider the slenderness ratio. Okay? The code provision says that the limit of the slenderness ratio for tension member is 300. So, yung slenderness ratio dapat ninyo is less than 300 or equal to, less than or equal to 300. Okay? So, yung slenderness ratio, you also have to consider yung slenderness ratio. Pagka pumasa dito sa design, mas mataas sa factor nyo, okay. Pero pagka chinek nyo yung slenderness ratio, bagsak naman siya. Like, for example, yung slenderness ratio ng steel ninyo is more than 300, you have to redesign again your section. You have to select another section. Okay? So, pagka sinabi nating slenderness ratio, that is L over R. Okay? Length over the R. Ito yung radius of gyration natin. This is also given doon sa properties ng steel. Okay? So, yung bago lang naman dito is on how to select yung ating section. Pagka meron na kayong trial section, anong gagawin ninyo? The analysis. Yung topic natin last week. Yun yung gagawin ninyo. Okay? So, let's have an example in the design. So, we have here for the problem 1, we have it, select a 10 meter A36. A36, we have Fy of 248 MPa and Fu of 400 MPa. W12 section. So, nakaspecify na yung depth na gagamitin natin na section. W12. Pagka hindi specified yan, you have to check all the sections in W. Section W12 ba yan? W8, you have to check lahat ng pasok doon sa minimum gross area ninyo. Okay? So, dito sa example natin, naka-specify that we must use W12 steel section. So, yung titignan lang natin is yung sa may W12. Okay? Steel section to support a tensile dead load. So, meron tayong tensile dead load which is 510 and live load of 410. Okay? So, in the figure, we have 2 bolts in each flange. So, dalawang bolt in each flange. And with a diameter of bolt equal to 20 mm. 3 bolts in a line with 75 mm on center. We have to use the LRFD method. Okay? So, sabi natin, we have to consider, so using LRFD, this is our solution. Okay. LRFD, ang kailangan natin is the factored load, the ultimate load. Okay, considering the necessary load combination, kasi LRFD yan, PU. Okay, so considering the necessary load combination, we have 1.2 dead load plus 1.6 live load. Pagka using the ASD method, yung PA natin is dead load plus live load. Okay, so we have 1.2 dead load, that is 510 plus 1.6 live load. Kindly calculate anong value natin dito. So what will be our ultimate PU load? Ilan?
2.8, ma'am.
1?
2.8, ma'am.
2.8? 2.8?
Yes,
2.8, ma'am.
yes.
Are you sure?
1268, ma'am.
1268. Remember, we have a dead load of 510. Tapos yung tensile load natin is 410. Saan nyo nakuha yung 2.8? 1.2 times 510 plus 1.6 times 410. That is 1268
1268.
kilo Newton. Okay? So, ito yung ultimate load natin. Okay? So, we have to calculate the minimum gross area required. So, minimum AG. Okay? Based on yielding. Okay? This is based on gross yielding. Okay? So, pagka gross yielding, ang fee natin dito is equal to, ilan yung fee natin dito? That is 0.9. Okay? I hope you still remember that. Okay? So, our minimum AG now is equal to PU over PFY. Okay? So, we have PU 1268 times 1,000, that is in Newton, over phi, this is 0.9 times Fy of 248. So, kindly calculate our minimum gross area.
5,681, ma'am.
5,681 mm squared. Okay? So meron na tayong minimum gross area. Okay? So based on this minimum gross area, we have now to select a steel section. Okay? So that we will have an assumption to have an idea in estimating yung whole areas natin if we consider yung minimum area based on the rupture. Okay? So, 5681. Okay, 5681. Punta kayo doon sa AISC manual natin. So, maghanap tayo ng section na yung area niya is mas malaki doon sa na-solve natin na minimum area. Okay? Wait lang. Naghahang. Okay? So, ito. W12. W12. So, puntahan natin yung W12. Okay, ito yung W12. Ito. Yan. Mga yan, W12 yan. Okay? This is in English. Parehas lang siya dito. Naka-SI lang dito. Okay? W12. Ang hanapin natin, maghanap tayo ng area which is greater than our estimated gross area which is 5681. Tignan natin dito sa area. Okay? 5681. Ito.
W12 by 35.
Okay. So, we select W12 by 35 since yung area niya is 6650. Mas mataas siya doon sa na-compute natin na 5681. Okay? So, we select W12 by 35. Okay? So, balik tayo dito. So, select W12 by 35. And W12, 35 have depth, BF, thickness of flange, thickness of width, ano pa yung kailangan natin, NDR. And of course, yung AG natin. Yung AG natin dito is 6650 mm squared. Ano yung magiging D natin? 12 by 35. D, 318, BF 167. 318 mm, 167 mm. TF, thickness of flange is 13.2 7.62. 13.2, 7.62. So we have 13.2 mm and 7.62. And for our R, we have 39.1. Okay? So we have, where is that? 39.1. RY, 39.1 mm. Okay? Mas maliit yung R na kukunin natin kasi pagka slenderness ratio na tayo, masosolve natin yung mas malaking slenderness ratio gamit pagka dinivide natin siya sa mas maliit na radius of gyration. Okay, so we have W12 by 35 with these following properties. Okay, so meron na tayong assumption. Kaya, based on minimum AG based on rupture, masosolve na natin yung minimum area gross based on rupture. Okay, so based on rupture, ang fee natin is equal to, remember magkaiba yung fee value natin pagka based on yielding and based on rupture. So fee natin dito is 0. Ilan ba ito? 0.75. Okay, tama? Okay, so solving for the minimum AG is equal to PU over phi FU times U. Okay? Plus, of course, this is only, this equation is for the net area. Ang kailangan natin gross area. So, mag-add tayo ng estimated whole area. Okay? So, mag-add tayo ng estimated whole area. Meron tayong PU. Okay? So, we have PU. 1268. Meron tayong phi, meron tayong FU. Ang problema natin, yung U. Okay? That is the shear lag factor. And then, yung estimated whole area. Paano natin kukunin yung estimated whole area? That is the number of bolts times the effective diameter of bolt times the thickness. Diba? Okay, so looking at our diagram, andito yung bolt natin, nasa flange. Okay, nasa flange. So ilan yan? 4. 2, 3, 4. So plus 4 times, ano yung magiging effective diameter natin? Remember, ang given is the diameter of bolt. Diameter of bolt is equal to 20 mm. Okay, so diameter of hole is 20 plus 2, 22 mm. Okay, since yung diameter of bolt is given is less than 24. And the effective diameter is equal to 24 mm. That is the diameter of hole plus 2 mm. That is 24 mm. Kaya plus 24 effective diameter of hole. Okay, times, ano pang kailangan natin? That is the thickness. Okay, whole area. So, ang kailangan natin is the thickness of nasaan ba yung hole natin? Nasa flange. So, ang kailangan natin is yung thickness ng flange. Nasaan yung thickness ng flange? That is 13.2. Okay? So, yung PU natin, 1268 times 1,000 in Newton times phi, 0.75 FU of 400 times U. Ano yung magiging U natin? Okay, balik tayo dito. So, balik tayo doon sa shear lag factors for connections. Naka-indicate sa problem na yung we have 3 bolts in a line. 3 bolts in a line. Okay? So, case 7 tayo. U calculated for case 2. Okay? Case 2. Di ba ang sabi natin, kukunin natin yung mas malaki. Okay? So, yung pinakamalaki dyan, with flange connected. Ito, with flange connected with 3 or more fasteners per line. Okay? So, you need to check BF is greater than or equal to 2/3 of the U is 0.9. BF is less than 2/3 of the 0.85. Okay? However, in here, nag-assume pa lang tayo, di ba? Nag-assume pa lang tayo ng section. Okay? So, kunin natin yung pinakamalaki. We have to assume that our U is equal to 0.9. Okay? Assume natin. Assumption. After which, pag sa analysis now, we have to check if our assumption is correct. Pagka nag-solve na tayo ulit ng value of U, gamit yung totoong trial section na natin. Okay? So, assume that U is equal to 0.9. 0.9. Okay? Assumption pa lang kasi itong section na W12. This is just based on the gross yielding. Okay? So, ano yung magiging minimum AG natin dito? Minimum AG based on the rupture. Kindly calculate this value.
5,900.
19.05, ma'am.
So, ilan ito?
5963.50.
We have 5960.50 mm square. Okay? So, 5960.5 mm squared. Pasok ba yung W12 by 35 natin? G is 66. Okay. W12 by 35 pa rin tayo. Okay? W12 by 35 pa rin tayo kasi ang minimum age is 5960. Yung gross area ng W12 by 35 is 6650. Okay. In cases na mas malaki yung minimum area gross dito kaysa doon sa assumption ninyo, yung unang assumption ninyo based on the yielding, you have to select another trial section. Okay? So, dapat yung trial section ninyo is mas malaki yung area gross in both based on gross yielding, tapos doon sa based on the rupture. Okay? So, pasok pa rin yung W12 by 35. So, gamitin pa rin natin yung W12 by 35. Okay? So, after selecting, so we have select W12 by 35 pa rin tayo. Okay? So, you will just copy. W12 by 35. Yun yung assumption. Yun yung trial section natin. Okay? So, meron na tayong trial section. Okay? So, pagka meron na tayong trial section, we have to check if since LRFD tayo, if our design tensile strength is greater or equal to PU. Okay? PU. I forgot. Before pala, kailangan din nating i-check yung slenderness ratio. Nakalimutan natin yung slenderness ratio. L over R. Ano yung L natin? That is 10,000. That is 10 meter. 10,000 in mm. R natin, based on this, is 39.1. So, ilan yung slenderness ratio natin? Wait lang. Mali. Ang kinukuha natin dito is the R, minimum R. So, L over R should be equal or less than or equal to 300. So, yung R natin is L over 300. So, L, that is 10,000 over 300. So, ano yung R natin dito? 10,000 divided by 300. Ilan ito? 33.33 mm. Okay? So, R minimum natin 33.33 mm. Pasok yung R natin na 39.1. So, pagka hindi pasok, another section. Okay? So, pasok naman yung 39.1. So, we consider W12 by 35. Okay? Now, pagka meron na tayong trial section, we have to check if our trial section is safe or not. Okay, paano natin i-check yun? We have to compare the design tensile strength doon sa ating ultimate load or yung factored load combination natin na PU. Okay, so paano natin kunin itong VRN? Okay, so unahin natin based on the gross section yielding. Based on the gross section yielding, ano yung magiging VRN natin? FP, 0.9. Rn natin is Fy, that is 248 times Ag. Ano yung Ag natin? Ag nung trial section natin, which is 6650. Okay, so ano yung VRN natin dito? Kindly calculate 0.9 times 248 times 6650.
1484280, ma'am.
1484.28 kilo
Zero, ma'am.
Newton. 28 kilonewton. Okay. So, yung na-solve natin na design tensile strength natin based on the gross section yielding, ano yung PU natin kanina? PU 1268. PU is 1268. Is greater than 1268 kilonewton. So, based on the gross section yielding, yung W12 by 35 is safe. Safe siya sa yielding. Okay? We also need to check yung sa net section fracture or rupture. Okay? So, before solving for the nominal strength, di ba? Yung VRN, pa rin tayo. Yung RN natin is FUAE, di ba? Meron tayong FU that is given. Solve first for the value of AE. Okay? AE is equal to capital U, that is the shear lag factor times net area. Okay? So, before solving for the effective area, we need to solve or we need to determine first the corresponding shear lag factor U. Okay? As the larger value from the table. Okay? So, we have our trial section W12 by 35. Pagka tinitignan ninyo yung half section, pagka W, ganyan yan. Pagka half, that is, tingnan natin yung WT shape corresponding to W12 by 36, that is WT6 by 17.5. Okay, so we need to check W6 times 17.5. That is 1/2 of our W12 by 35. So we can get for the value of X bar. Okay? Since yung U natin, in solving U, meron tayong case 2. That is U 1 minus X bar over L. Okay? X bar natin, kailangan nating kunin. I-check natin yung WT6 times 17.5. That is the half of the W12 by 35. Kung ano yung X bar natin. Okay? So, WT, dito sa baba yung WT natin. WT, yun. WT6 by 17.5. Ito. So, ang X bar natin is yung 33. Okay? 33 mm. Remember, ito yung X bar natin dito. Ito. Ito yung magiging X bar natin. Kaya, Y yung tinitingnan natin. Kasi andun sa flange yung bolt natin. Okay? Ito. Pagka nasa web naman yung bolt natin, ito naman yung X bar natin, yung X. Okay? So, balik ulit tayo sa solution natin. X bar, ilan yung X bar natin? 33. Tama? 33 ba yung nakikita natin kanina?
Yes, ma'am.
Okay, so
Yes,
kindly
ma'am.
solve. Ano yung L natin? Given yung L sa problem, sabi 75. So 75 plus 75, that is 150. Remember, yung L natin is from the edge, center to center of the bolt. Okay, so our L is 150. So kindly solve for our capital U.
0.78. 0.78, ma'am.
So we have 0.78. Okay? And yung case 7, with 3 or more fasteners per line, we have to check if BF is greater than or equal or less than doon sa 2/3 of D. Right? Kasi dalawa yun eh. Tignan natin ulit. Dalawa yun eh. Ito. With flange connected with 3 or more fasteners per line in direction of the loading. Dalawa. Either 0.9 or 0.85. Okay? So, i-check natin yung BF if if it is greater than or equal to 2/3 of D, for us to determine if our shear lag factor is 0.9 or 0.85. Okay? So, i-check natin. Ano yung BF natin? 167. So, 167, is it greater than or equal to 2/3 of D? 318. Ano yung 2/3 ng 318? 2/3 of 318. 212.
12, ma'am.
212, ma'am.
212. So, ano ito? 167 is less than. So, pagka tinitignan natin, less than, yung U natin is 0.85. Oh, so, U is equal to 0.85 kasi less than yung BF natin kaysa doon sa 2/3 of D. Okay? So, therefore, use the larger value of U between these two. The larger value of U is 0.85. Okay? So, use this larger value of U. Okay? So, meron na tayong, so to solve for the AN, AE is equal to U times AN. Ang U natin is 0.85. Ano yung magiging AN natin? AN, the net area, is equal to area gross minus DE times thickness. Diba? Yung area gross natin is 6650 minus the summation, that is ilan yung bolt natin? 4. Times the effective diameter, that is 24, times the thickness, 13.2. So, kindly solve for our net area. Net area is equal to
5382.8.
5382.8
382.
mm square. Okay. So, ito na ba yung value ng AN natin? 5382.8. Ito na ba yun? So, do not forget the code specify the limit of AN. Okay? Sabi ng code, yung AN should be less than or equal to 0.85 of AG. Okay? So, yung computed net area natin is 5382.8. Okay? Yan yung computed net area natin. I-compare natin siya sa 0.85 of AG kasi meron tayong limit ng net area. Okay? Dapat yung computed net area natin is less than 0.85 of AG. Okay? So, pagka mas malaki yung computed net area nyo kaysa doon sa 0.85 of AG, anong gagamitin nating AN? Yung value dito, yung 0.85 of AG. Okay? So, kailangan mas maliit yung computed AN natin doon sa 0.85 of AG. So, kindly compute for the 0.85 of area gross. Ang area gross natin is 6650. Ilan yung 0.85 of area gross natin?
5652.5.
ma'am.
5652.5 mm
Yes,
square.
ma'am.
Okay? So, pagka tinitignan natin, AN natin is 5382.8 mm square. This is less than or greater than? Less than. Okay? So, this is less than. So, yung computed AN natin is, ito na yung magiging AN natin. Okay? So, okay siya. So, pasok pa naman yung computed AN natin. In instances na mas malaki yung computed AN ninyo, for example, yung computed 0.85 of AG ninyo is 5,000. So, mas malaki yung AN ninyo. Ang gagamitin yung net area is yung value dito, yung 0.85 of AG, which is 5,000. Kasi meron na tayong limit for the net area. Okay? So, I hope you understand that. So, ito yung magiging AN natin. Therefore, our net area is 5382.8. Since okay naman siya dito, that is less than 0.85 of AG. So, 5382.8 mm squared. We can now solve for the value of the effective area. Ano yung magiging value ng effective area natin? 0.85 times...
4575.38, ma'am.
So, we have 4575.38. Okay?
38.
38. Okay. 38 mm squared. Ito yung AE natin. So, AE pa lang yan. Ang kailangan natin is to solve for the design tensile strength. Okay, so to solve for the design tensile strength, that is phi times Rn. Okay, ang Rn natin is, ano yung Rn natin? Fu times Ae. Okay, so meron na tayong value. We can now solve for the design tensile strength, that is, anong phi natin? 0.75. Okay, remember this is based on the rupture. 0.75 times Fu, that is 400 MPa, times AE, which is 4575.38 mm squared. So ano yung magiging value ng phi Rn natin? So that is the design tensile strength.
1426.14.
So ilan ito?
1372.614, ma'am.
1372.61.
1.
Ma'am, han ba nga 1426.14?
Paki-check nyo nga, yung iba is 1.4 daw. 0.75 times 400.
1372.61.
So we had 1372.61 in kilonewton. Okay? Since yung na-solve ninyo sa calculator ninyo, that is in Newton. Okay? So 1,037,2614, that is in Newton. Since MPa tayo dito, tas mm tayo dito. Newton ang lalabas. So 1372.61 kilonewton. Is it greater than or less than yung PU natin, which is, ano yung PU natin? 1268. Greater than? So, mas malaki yung design natin kaysa doon sa ating PU. So, our section is safe. So, safe yung section natin. Kasi mas malaki yung design tensile strength natin kaysa doon sa ultimate load natin, PU. Okay? So, safe yung section natin. Based, if we consider yung rupture. Okay? So, if we consider yielding safe yung W12 by 35, if we consider rupture, safe din yung W12 by 35. Kindly off your mic, Mr. Daugas. You're distracting me. Mr. Daugas, Jedfrey, kindly off your audio. Mr. Daugas.
Sorry, ma'am. Sorry.
Okay. So, our W12 by 35 section is safe in both yielding and rupture. Okay. So, we also have to check yung slenderness ratio natin, yung L over R. Okay. So, L, 10,000. Ang R natin, W12 by 35, have an R of, ilan ba yung R natin? 39.1. 39.1. So, ilan ito? 10,000 over
255, ma'am.
255.75. Okay? So, yung slenderness ratio natin, L over R, is less than 300. Ito yung limit natin for tension member, 300. So, okay siya sa slenderness ratio. So, yung W12 by 35 natin is okay doon sa slenderness ratio. Safe siya sa yielding and rupture. Safe siya. So, we can conclude that we have to use W12 by 35 in both gross section yielding and net section rupture. Okay? So, we have to use W12 by 35. Okay? So, ito na yung trial section natin, W12 by 35. Ito na yung sagot natin. In cases na hindi okay yung na-solve din yung design tensile strength, mas malaki yung PU or the ultimate load, you have to change your trial section. So, mag-select kayo ulit ng trial section. Okay? And for instances that the problem states that you have to select the lightest weight, the lightest or the most economical section, you have to select, okay, pagka tinitingnan natin yung section natin, meron tayong weight, di ba dyan? Meron tayong weight. Yan. Okay? So, most economical section, mas mababa yung weight natin. Okay? So, yung pagka sinabi kong choose the lightest W12, ang section natin is W12 by 35, right? 12 by 35. 12 by 35, nasaan na yun? Ito. Okay? There are instances that W12 by 30 is also safe. So, kailangan yung i-check yung susunod dito, W12 by 30. Okay? There are instances. Kasi assumption lang naman yung ginawa natin doon sa gross, di ba? Na at least malapit siya sa minimum AG is ilan yung na-compute natin kanina. There are instances na yung kasusunod dito mas okay pa rin siya. Okay siya. There are instances. So pagka sinabing lightest or the most economical, yung trial section na una niyong kinuha, kunin niyo yung mas mababa pa dito. I-try niyo rin siya. Okay? Since there are instances, sabi ko nga, na pwede din yung W12 by 30. Okay? And since sa problem, ang in-indicate kasi na ang kailangan natin kunin is W12, kaya ito lang yung tinitignan natin. In cases na walang in-indicate na W12 ang section natin, say W section, yun lang yung sinabi. Okay? So tignan nyo yung W12, 6650. Tignan nyo din yung W10, 6650. Ano yung area natin kanina? 56. Ano yung na-solve nating area kanina? 59? 56? 59.
5681, ma'am.
59. 59. Ito, pwede dito. W10 by 33. Okay? Lahat ng W10 by 33, ang weight niya is 49.1. Ang W12 by 35, ang weight niya is 52. Pwedeng ito, yung kunin nyo, W10 by 33. Kasi ang weight lang niya is 49.1. Tapos yung area niya is 6260. Okay? So pagka sinabing economical W section lang, pwede nyo i-try ito, W10 by 33. Kasi ang weight niya 49.1 compared doon sa kanina, yung W12 by 35, that is 50 plus yung weight niya. So mas economical pag W10 by 33 yung gagamitin ninyo. Okay? So i-try nyo yung W10 by 33. Pagka hindi sinabing specified yung depth ng W section ninyo. Okay? Pagka sinabing W lang, i-try nyo yung W10, tignan nyo yung W12, then compare. Pwede din ata dito sa W8. Tignan natin sa W8. W8, ang area natin is 59. Ito, 6650 by 35. Pero 52 yung weight niya eh. 52 kilogram per meter. Mas economical pa rin yung 10 by 33 kasi 49. Okay? Ganyan. You have to check all W section. Pagka W lang yung nilagay. Pagka S section, you have to check all S section. Okay? Pagka in-indicate po na ang kukunin nyo is W14 o may depth na kayo, you have to focus your in selecting yung trial section ninyo doon sa W14 lang. Okay? So, ganun na. Ganyan. Kaya, nag-focus lang tayo doon sa W12. Naka-specified kasi sa problem na W12 yung gagamitin. Okay? Ay yung kukunin na section. Meron na akong specified depth. Okay? Pagka wala, i-try nyo lahat ng W section na pwedeng economical. Lalo na pagka binanggit sa problem that you have to select the lightest or yung select the most economical section. Okay?